Hey everyone, welcome back to the channel. Today, we're diving deep into two fundamental concepts in natural language processing that every data scientist and ML engineer needs to know: stemming and lemmatization. If you've ever wondered how Google understands that running, runs, and ran all mean basically the same thing, or how chatbots know what you mean even when you use different word forms, this video is for you. By the end of this video, you'll understand exactly what these techniques do, when to use each one, and you'll see real Python code examples. So let's jump right in. All right, before we dive into the technical stuff, let's talk about why this even matters. Look at this. Without normalization, a computer sees running, runs, and ran as three completely different words. That's a problem because these all represent the same core concept: the action of running. But with normalization, we can convert all these variations into a single form: run. Now the computer understands they're related. This is absolutely critical for things like search engines, sentiment analysis, chatbots, and pretty much any NLP application you can think of. Without text normalization, your models would be overwhelmed by vocabulary size and miss important patterns. Let's start with stemming, the faster, simpler approach. Stemming is a rule-based process that literally just chops off the endings of words to get to the root form, which we call the stem. Look at these examples. Playing becomes play. We just removed ing. Connection becomes connect. We removed ion. Pretty straightforward, right? But here's the catch. Studies becomes studi. Notice something? That's not even a real English word. And that's the main limitation of stemming. It doesn't care if the result is valid or not. It just applies rules mechanically. On the plus side, stemming is super fast and very lightweight. On the downside, you get these weird non-words, and it has zero understanding of context or grammar. Think of stemming like a very aggressive word trimmer. It gets the job done quickly, but not always prettily. Now, there are actually several stemming algorithms, and they vary in how aggressive they are. The Porter stemmer is the most popular. It's been around since the 1980s and strikes a good balance between speed and accuracy. Snowball is an improved version of Porter. It handles more edge cases and supports multiple languages. And Lancaster is the most aggressive. It chops words down even more heavily, which can lead to more non-words, but might be useful in some cases. Let's look at some actual Python code. Here, we're using NLTK's Porter stemmer. We import the stemmer, create an instance, and then stem some words. Notice the output. Running and runs both correctly become run, but easily becomes easily. That weird non-word problem again. This is real code you can run right now. I'll drop links to the documentation in the description below. Now, let's talk about lemmatization, the smarter, more sophisticated approach. Unlike stemming, which just chops words, lemmatization actually understands them using dictionaries and linguistic rules. Look at these examples. Studies becomes study, which is a valid word. Better becomes good because lemmatization knows better is the comparative form of good. And running becomes run, but it actually understands it's a verb. This is the key difference. Lemmatization uses part-of-speech tagging and dictionary lookups. It knows whether a word is a noun, verb, or adjective, and it finds the proper base form. It uses tools like WordNet, which is basically a massive lexical database, along with morphological analysis to get linguistically correct results. Think of lemmatization as a language expert, not just a word trimmer. Let's see lemmatization in action with Python code. Here, we're importing word lemmatization from NLTK and downloading the necessary data files. Then we lemmatized our words. Notice that second parameter, V for verb. This is the part-of-speech tag I mentioned. You can use N for noun, A for adjective, and so on. Notice the results: running to run, ran to run, all valid words. Though notice better stays better when we use verb tagging. If we used A for adjective, it would correctly become good. The trade-off here is clear. Lemmatization gives you much better accuracy and always produces valid words, but it's slower and needs more computational resources. In production systems, this trade-off between speed and accuracy is super important, which we'll talk about in a minute. All right, let's put these side by side and really see the differences. Approach. Stemming uses simple rules. Lemmatization uses dictionaries and grammar. Output. Stemming might give you nonsense. Lemmatization always gives valid words. Speed. Stemming is lightning fast. Lemmatization is noticeably slower. Accuracy. Stemming is rough. Lemmatization is precise. Context. Stemming ignores it completely. Lemmatization is context-aware using part of speech. Use cases. Stemming for search and indexing where speed matters. Lemmatization for machine learning models and chatbots where meaning matters. This table is your cheat sheet. Screenshot it if you want. Let's see some concrete examples side by side. Running. Both techniques handle this well and give us run. Studies. Stemming gives us study, which is garbage, but lemmatization correctly gives us study. Better. Stemming gives bet, but lemmatization understands this is the comparative of good and returns the proper base form. For fairly, stemming strips it to fair, while lemmatization keeps it as fairly because that's already the base adverb form. And caring. Both get it right this time. See the pattern? Stemming is fast but crude. Lemmatization is slow but intelligent. It's really that simple. Okay, this is the million-dollar question. When should you use stemming versus lemmatization? Use stemming when you're building a search engine or information retrieval system where speed is critical and you're processing millions of documents. You have limited computational resources. Maybe you're deploying on edge devices or mobile. You need real-time processing and milliseconds matter. Or when small inaccuracies won't significantly impact your results. Use lemmatization when you're doing sentiment analysis where the exact meaning of words is crucial. You're building chatbots or question answering systems that need to truly understand language. You're working on machine translation where linguistic correctness is non-negotiable. Or text summarization and topic modeling where quality trumps speed. Here's my simple rule of thumb. If you're prioritizing speed, use stemming. If you're prioritizing accuracy and meaning, use lemmatization. In my experience, modern NLP applications usually go with lemmatization because computational resources are cheap and accuracy is valuable. But for big data applications like search engines, stemming is still king. Let's zoom out and see where stemming and lemmatization fit in the bigger picture of an NLP pipeline. First, you start with raw text, maybe customer reviews, tweets, whatever. Then tokenization. You split that text into individual words or tokens. Next, stop word removal. You remove common words like the, is, and that don't carry much meaning. And this is where stemming or lemmatization happens, right in the middle. This is your normalization step. After that, you do vectorization, converting words into numbers that machine learning models can understand. Finally, model training, where your ML or AI model actually learns from the data. Libraries like MLTK, Spacey, and Hugging Face make all of this incredibly easy. They have built-in pipelines that handle these steps almost automatically. Understanding this pipeline is crucial because text preprocessing can make or break your NLP model's performance. All right, let's bring this all home with the key takeaways. Stemming, fast, efficient, simple to implement, but it can produce non-words and it's context ignorant, great for speed-critical applications. Lemmatization, linguistically accurate, always produces valid words, context-aware, but slower and needs more resources, great for accuracy-critical applications. And here's the big lesson. There is no one-size-fits-all solution. The best choice depends entirely on your specific use case. So next time you're pre-processing text data, ask yourself this question. Do I need speed or do I need understanding? Answer that, and you'll know which technique to use. This is one of those fundamental trade-offs in computer science, speed versus accuracy. You'll see this pattern everywhere, not just in NLP. And that's it. We've covered stemming, lemmatization, the differences, when to use each one, and seen real code examples. If you found this helpful, please hit that like button. It really helps the algorithm show this video to more people. And if you're not subscribed yet, definitely subscribe and ring that notification bell so you don't miss future NLP tutorials. Thanks so much for watching, and I'll see you in the next video. Happy coding!